All right, so we're going to start here today with an example. And we have a function g of x equals, in factored form, x minus 3 times x plus 2. So if I were to ask you what the solutions are when g of x equals 0, then we would simply use the zero product property. We'd set x minus 3 equal to 0, x plus 2 equal to 0, and we get two solutions, x equals 3 or x equals negative 2. Now, these solutions are what we're going to call roots of the equation. That's a new word that we haven't used yet, but they're going to be called roots. The zero, sometimes the roots are referred to as zeros, but the zero of a function is the x value that makes the function value 0. So since we know the solutions are 3 and negative 2, then 3 and negative 2 are considered zeros of the function. So you'll notice that we use the word zero or roots sometimes interchangeably. Now they both revolve around what we call x-intercepts. The x-intercepts of this graph are going to be 3, 0 or negative 2, 0. So it's important in your head that you differentiate between solutions, roots, zeros, and x-intercepts. They're all related together. So what are the zeros of f of x equals x plus 4 times x minus 7? Here are your options. Think about what the zeros of this function are. I'm going to tell you that the answer is not C or D, because C and D represent x-intercepts. So the answers are either going to be A or B, but keep in mind we have to solve each of these by setting them equal to 0 and solving for x. So we end up getting negative 4 and 7. Now, the graph of a function crosses the x-axis at 2, 0. There's an x-intercept. What must be a root of the equation? In other words, what is the value of x that makes the output equal to 0? Don't overthink this one too much. Since we know the x-intercept is 2, 0, then the root must be x equals 2. Okay, so let's look at two polynomial functions. We have p1 of x, which is this function here in factored form, and we have p2 of x, which is this function here. Here are both of these functions graphed. p1 of x is in red, p2 of x is in blue. Now, we can find the zeros of the red graph by simply taking each of these factors, setting them equal to 0, and solving. So one of the zeros is 1, the other 0 is positive 2, and the third 0 is positive 3. And we have those represented down on the graph right here. Now we can see that when x is less than 1, based on the graph, the output of the graph is going to be negative. As soon as we go between 1 and 2, when x is a value between 1 and 2, the output changes sign. It goes from negative to positive. Between 2 and 3, it changes sign again, goes from positive to negative, and then finally when x is greater than 3, the output is positive. And we're using positive and negative as below the x-axis or above the x-axis. If the output is below the x-axis, then the output is negative. If the output is above the x-axis, the output is positive. Let's look at the blue graph. The zeros, we set x minus 1 equal to 0, we get 1. We set x minus 3 equal to 0, we get 3, but notice that x minus 3 is written twice here. So we don't have to write the 0 twice. But let's see how that affects the graph. When I'm to the left of negative 1, we can see the graph is negative. Between 1 and 3, the sign changes and it goes positive. But look what happens at 3. At 3, once it hits 0, when we go above 3, when x is above 3, it remains positive. X minus 3 is listed twice, and as a result, the graph doesn't change signs when we're to the left of 3 and when we're to the right of 3. This concept is known as multiplicity. It's called multiplicity. And if we look at the multiplicity of x minus 1, because there's only one factor, the multiplicity is going to be 1. X minus 2, there's only one factor, so the multiplicity is going to be 1. And x minus 3, there's one factor, so the multiplicity is 1. But in P2 of x, the blue graph, x minus 1 has a multiplicity of 1, but x minus 3 has a multiplicity of 2 because there's two factors. And what we notice is that because there are two factors, the graph didn't change signs around that 0. All right, it stayed positive here and it's positive here. Okay, so when we look at these multiplicities, we can say that if the multiplicity is odd, then the graph is the outputs are going to change signs about that 0. But if the multiplicity is even, here's an even multiplicity, then the graph or the output does not change signs. So an odd multiplicity, the sign changes. An even multiplicity, there is no sign change. If it's positive, it remains positive. If it's negative, it remains negative.